So for this problem, we're going to assume that the circuit is in saturation. We're going to start out with the equation for the drain current, which we know is this. We are given this value and this value, but we don't know what the drain current is, and we don't know what this is. So we know that that Vs, which is this, is equal to V4, and since this is connected to ground, this is 0, so we're gonna plug in 0 minus V4 for this. And so if we plug everything in, we're gonna get for the drain current this equation. And we also know that the drain current is equal to V4 minus negative V5 divided by 1K if we do a KCL. And so these are both equations for drain current, so we can make them equal to each other. And then we just solve, so multiply by 1K on both sides, we get this, then cancel this out, and we factor this out, and we're gonna get this, then subtract both sides just to make the equation equal to 0. And then once it's equal to 0, you can use the quadratic formula to find the values for V4, or what the roots of this equation are. And in order to find what V4 is, we know that VGS must be greater than VTH. So, and VGS is equal to 0 minus V4. So we're going to test both of these. So for the first value of V4, we would get VGS is equal to 2.33 volts, which is greater than VTH. And for the second root that we found, we would get that VGS is equal to negative 1.933 volts, which is not greater than VTH. So V4 has to be equal to this value. And then once we found V4, we can plug that back into the equation and solve for the drain current in order to find what V5 is by doing a KCL here. So you just plug everything in, we get this value for the current. Then we do here 5 volts minus V5 divided by 2K is equal to the value that we found for the drain current. And solving for V5, we get that V5 is equal to negative 0.313 volts, or negative 313 millivolts.